to review, we're going to talk about linear equations. And you can see here that we have the slope-intercept form. That is actually what is on our star mathematics chart. It says slope-intercept form, and then right next to it, it has this equation, y equals mx plus b. So we have been covering what each of these mean. So just to review, before we go into our actual algebraic calculations, let's talk about what each piece of this equation means. So m is our slope. There are many names we could use for m right now. We could use slope, and to find slope, we know that it's delta y over delta x. Okay, some of you guys, we've said also rise over run. Okay, so that is definitely our slope. M also, we would call it our coefficient, the number that is with the variable. Okay, so that being said, we can come over here, and B is our Y-intercept. That's basically the point where your linear equation, your line, right, where it crosses, this is your y-axis, so right here on this particular graph would be where it intercepts or crosses the y-axis. So we can call it the y-intercept. We will also, if this m is the coefficient, we can call this one the constant. Okay, another term you may hear it called would be initial value. Absolutely, it's going to be the initial value. You're going to hear that more in a word problem. Another term we can use for slope, one that we've been using in class. Okay, this is where you're going to find your rate of change. Okay, especially if you're looking at, again, a word problem, your rate of change is going to be something that is found where your slope is found. Okay, so really quickly, a couple more things. X, it is your variable, but this one is your independent variable. And if x is the independent variable, that means that y is your dependent variable. Basically, y depends on what you plug in for x, and we're going to see that here in just a minute. So just a little overview of the slope-intercept form and what each one of those pieces are going to mean for us. Okay? So let's start with taking an expression and making it into a t-chart. You guys have done this many times, so we're just going to review. So the first thing that I would say is, here's your expression. Okay, you probably can go ahead and pick out your slope and your y-intercept. So before I even take this to a t-chart, I really could pick out where the y-intercept would be on a graph, pick out what the slope would look like on a graph. So your slope is your coefficient, so your slope would be 2, and your y-intercept, a lot of you guys would probably say 5, but this subtraction sign goes with this 5, so this really is a positive 5. If I were to do LCO, leave, change, opposite, this is actually a negative 5. So negative 5 would be your y-intercept here. So we could say that m is 2 and b is negative 5. Okay? So let's go ahead and take this expression and make it into a t-chart. So all that we have to do is take the expression that we are given, which is right here, and we're going to plug in for x. Okay? So they have given us some x values. You'll see them over here on this side. And all we're going to do is take our expression and plug in these x values where we see this x. So this says 2 times x, and so for x, we're going to plug in negative 2. And the rest of our expression says plus negative 5. Okay? This is where order of operations comes in. 2 times negative 2 is negative 4, and negative 4 plus negative 5 is negative 9. So that would be our first value. So when x is 2, y is negative 9. Okay? So let's go to our next x value. Same thing. We take our expression 2 times and we plug in for x. So in this case, we're plugging in negative 1, and again, plus negative 5. So 2 times negative 1 is -2 plus -5, -2 plus -5, they're on the same team, so that's going to be -7. Okay, you might be able to kind of sense a pattern here, but we can't tell that until we have 3 values in a row. So let's plug the next one in. 2 times, in this case, we're going to plug in 0 plus -5. So 2 times 0 is 0 plus -5 is definitely -5. Okay, so those of you who are paying attention, you absolutely should see over here on this side, we do have a little pattern happening. So from -9 to -7, we increased by 2. The same thing happened here, -7 to -5, we increased by 2. So really, I could go ahead and do these next couple of values. I should know -5, if it increases by 2 again, is going to be -3. And the same thing, if that one increases by 2 again, then I should get -1. Okay? I tell my kids that we have to have at least 3 things plugged in, just like right here. Plug in for 3, and then if you can see the pattern on the last 2, then you can go ahead and use that pattern. Okay? So all we did was we took our x values over here, and we plugged them in for x. All we did was we took an expression and made it into a t-chart. So we're going to use this same t-chart, okay, to make a graph. Okay, same t-chart to make a graph. So our t-chart here, let's go ahead and draw it. We had x was -2, -1, 0, 1, and 2. And our y value started at -9, -7, -5, -3, and -1. So as we're putting this on the graph, if these are the x values, that means these over here are the y values. So really these just make points on a coordinate plane. So your first point is this right here. So when x is -2, y is -9. So some of you guys probably would like to have it written like that. It would be a little bit easier. So for me to graph this, we start at the origin, and notice there are no numbers on this graph. You're not always going to have numbers, but we do need to remember where to graph things. So -2, if this is our x and this is our y, that means we go back 2, that's -2, and down 9. 6, 7, 8, 9. Okay, so that's our first point. So we got that one. Next point would be -1, comma, -7. So we start at the origin. -1 means back 1. -7 means down 7. 1, 2, 3, 4, 5, 6, 7. Okay, got that one. Next one would be 0, comma, -5. 0, comma, 1, 2, 3, 4, 5. Some of you hopefully are noticing that that right there is your Y-intercept. And we'll talk about that a little bit more here in a minute. Okay, the next point is 1, comma, -3. So start at the origin, over to 1, down 3. And the next one, 2, comma, -1. Okay, so what you should notice is a little pattern along your graph. And again, we said that we're working with linear equations, which you can tell in this little word linear. You see the word line, so yours should make a line, okay? So when you draw your little line through it, hopefully it makes a line. That's pretty good. If they're all lockjawed, it's probably not correct. Either our graph did something wrong or our t-chart did something wrong. So if we're looking at this y-intercept, just want to take a moment. This right here, I'm going to highlight it. This is the y-axis, okay? The only thing that the y-intercept means is where your line crosses the y-axis. I know some of you guys play football, interception, right? Another player comes and intercepts the ball. It's just where your line crosses the y-axis. So this line crosses the y-axis at -1, 2, 3, 4, 5. Which is exactly what we said, because our original expression, b, which was right here, this was b, and we said b is the y-intercept. So all of these things should be kind of coming together, you know, as you're looking at them. You can get the slope from the graph, you can get the slope from the t-chart, you can get the t-chart from the graph, all of those things kind of work together. Okay? So we're going to go from graph to expression. And I'm going to put a graph up here. We're going to do a couple of them so you can kind of tell kind of what's happening. Okay? So we'll start here. And all right. So what we need to fill in is y equals mx plus b, where m is your slope and b is your y-intercept. Okay? Again, m is your slope, b is your y-intercept. I think that b is the one that is the easiest to do. All you have to do is look at the graph for where your y-intercept is. So here's the y-axis. And where in the world did my line cross on that y-axis? It crossed right here, and that's at +2. So all I do is I put a 2 where the b would have been. Okay? I think the y-intercept is the easiest piece to find. Okay? So then, I'm going to write that 2 back. If we're looking at the slope, okay, the slope is m. Our formula for finding slope is delta y over delta x. And remember, delta just means the change in something, okay? How much something changed. So it's just a formula, that's all it is. So you go from one point to the next point, and the change in y is basically how much did the y-axis change from this point to this point. How much did you either rise, okay, or fall? And in this case, from here, from this point to this point, we had to go up just 1, right? So our delta y would be +1. We went up 1, okay? The change in x, delta x, is how much did it change on the x-axis. So we also call that run. So this is rise over run. So from here, this point to this point, it changed 1, 2, 3. Rise over run. So delta x, the change in x, would be 3. So in this case, I can tell that my line is increasing, okay, because it's going up and to the right, it is increasing, and also my slope here is +1/3. So I would take my slope, and I would leave it as a fraction. We actually, fractions are our friends. We leave slopes as fractions. It's much easier than changing them to decimals. So this would be 1/3. And that just tells me the pattern of my graph. My graph goes up 1 over 3, up 1 over 3, up 1 over 3. I could continue to graph it, for quite some time if I needed to. Okay? So let's do another one. And let's see. Okay. Again, same thing. Y equals blank x plus blank, where this is your slope, or m, and this is your y-intercept, or b. Hopefully, I want you to take a look at the graph, and hopefully you see the y-intercept. Okay? The y-intercept at this point, you can see it pretty clearly. It is at the origin, which means 0. Right? It crosses at 0. All right, so got 0 there for b, and then your slope, we go back to that same formula we've been using, delta y over delta x. So the change in y from here to here, from one point to the other. Here's a good question. I'm going to go from one point to the next closest point because it's less for me to count. Now, if I wanted to go from this point to this point down here, could I find the slope that way and do the change in y and the change in x? Yeah, I absolutely could. The slope is going to come out to be the same, but it's easier to count smaller distances. So we're going to use these first 2 points, and we always read from left to right. So that's why I'm starting with this one right here. So the change in y, that's how much our y values have changed. Rise or fall is what we're looking for. So rise, it actually went down. To get from here to here, it went down this many. So let's count. 1, 2, 3, 4, 5. So the change in y, I'm going to say, is down 5. And down 5 means that your slope is going to be negative, right? Negative slope, your line is decreasing, all of those terms that we've been using in class. Delta x, okay, is the change in the x value. So from here to here, we went down 5, and we went over 1. Okay? So I do want to call your attention to one thing. If you look right here, this says negative 5 over 1. So a lot of you would be tempted in your final answer to write negative 5 over 1, kind of like this. Okay? Well, the problem with that is it's not in simplest form. So negative 5 over 1, I can actually simplify that. 5 divided by 1 just equals 5, and a negative divided by positive is a negative. So this slope would just be the whole number, negative 5. Okay? So that's kind of what we would be looking at right there, 5x plus 0, or negative 5x plus 0. You would also probably see it written like this, negative 5x, because they're not going to write the plus 0, right? If somebody owes you $0, you don't go up to them and say, hey, can I have $0? You just don't say anything at all. So they would probably write it something like this. Okay? All right, one more thing, and then we're done. We've got a t-chart, and we're actually going to go backwards. We started with the expression and went to the t-chart. Now we're going to go from the t-chart to the expression. I just want you to see that all of these things go hand in hand. Same thing, linear equation. Y equals blank x plus blank. Okay? The only thing different is that instead of having a graph, I have this t-chart. So the first thing I would say, find your y-intercept, or b, and remember that's where x equals 0. And not every t-chart's going to have it on there, but I think we see it here. So where x equals 0, right here, we have an 11. So my y-intercept is going to be 11. I can tell already just by looking at where x equals 0, y is 11. So that's your y-intercept. The only other thing we need to find is our slope. Same formula for slope. Delta y over delta x. So let's plug in what we know. Delta y, the change in the y values here, I can see it in my head, but if I couldn't, to find the change in something, you just subtract. So 15 minus 13 is 2, and they actually are decreasing by 2, so that would be minus 2, right? Negative 2. Okay? And then the change in your x values, from negative 6 to negative 3, they increased by 3. So your slope, we could leave it just like that. It's simplified and everything. So negative 2/3 x plus 11. Just remember, all of these things go hand in hand. And if you can go back to this diagram right here and remember that slope is delta y over delta x, and b right here is your y-intercept. That's going to help you so much.